12.1, example 2, letter A. These are like problems 11 through 28 in the book from section 12.1. We're supposed to estimate each one-sided or two-sided limit if it exists. A one-sided limit simply means we will only be calculating the left hand or the right hand limit, not both. Two-sided limits are what we did in example 1a, where we were looking at both the left and the right side and then drawing a conclusion about the overall limit. For example 2a, we have the limit as x approaches 3, but it's not going to be the overall two-sided limit that we're looking at. We just need to do the left-sided limit, the numbers that are a little bit smaller than 3. So normally when we would go through and make our XY table, what we would do for this section is we would make a table with 7 values in it. Something like this. And then from there, we would look at this number. X is approaching 3, so we would take that number and we would put that here. And then for our x values, we would add 1,000th, 100th, and 1/10, and subtract 1,000th, 100th, and 1/10 to get the numbers on either side. For this problem, though, we only need to go through and calculate the left-hand limit. So instead of making a table with 7 values in it, we only need the ones that have x's that are a little bit smaller than 3. So we're not going to be using those last 3 boxes at all. So our table this time could just look like that. In addition to that, remember we do not need to calculate the y-coordinate at this value. We're just looking at what happens when we get close to the value, in this case from the left side, from the numbers that are a little bit smaller. So grabbing my calculator, I'm going to go into y equals. I'm going to type in our equation. We have an absolute value in this problem. Where the absolute value command is, you want to go into math, which is right below alpha. We have some menus there at the top. We want to use the right arrow to go over to the num menu. And then ABS, the first selection there, is what we want. And we want the absolute value of 2x. And then we'd want to close off those parentheses. And then we're dividing that by a 2-term polynomial, so we'd want that in parentheses too. So divided by, in parentheses, x plus 1. So there is our equation in our calculator. And then from there, we are going to go through and put in the values that are a little bit smaller than 3. Those values again, we want to take 3 and subtract off 1,000th, 0.001, 3 and subtract 100th, 0.01, and 3 and subtract 1/10, or 0.1. Now I can type in those 3 x values and calculate our y values with our calculator. I still have this on Ask Auto, so that I can type in these x's and it will calculate the y values instead of automatically filling up both of those columns. I only have 3 numbers to type in this time, so I'm just going to hit the delete button a few times here and get rid of the ones that were there from the last problem, and then type in our 3 values. And then from there, I'll take and write these y coordinates into the corresponding y values in our table. So there's our completed XY table for the left-hand limit. We're supposed to estimate each one-sided or two-sided limit if it exists. In this case, we're just doing the left side, so it is a one-sided limit. Taking a look at what we have over here on this left side, we do want to see as our x values approach our value in our limit, what are our y values doing? Well, we have 1.487, 1.498, 1.4999. Looks like to me they're getting very, very close to about 1.5. So our final answer for this left-hand limit, the limit as x approaches 3 from the left side of our equation of our y value, that it looks like to me our y values are getting closer and closer and closer to 1.5.